meaning like sine is going to be equal a specific ratio. Ratios are just fractions. They're all going to be related to an acute angle. And then based on whichever acute angle you are looking at, you will label the sides as adjacent, meaning it's the side touching the acute angle. Opposite would be the one directly opposite, and hypotenuse is the longest side. So don't get this side confused with adjacent, because this side touches it, but it's the longest. The longest side is always called the hypotenuse. Good. All right, so what I'm going to give you guys is the way these are defined first. Then once we got them defined, then we'll go through actually like plugging in some numbers, and then it'll lead from that all the way into actually doing a problem where you're finding the side length. So it starts with real basic stuff. All right. So sine, the way it's defined, is opposite over hypotenuse. Okay? Opposite, again, opposite is all just related to whichever angle you're looking at. Sine, guys, opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, and then I'll say something like, based on the triangle that's up there, right, the sine of r. Okay, so it's not finding anything. All it's asking you to do is write the ratio. Okay, so this isn't like a solving problem. It's just a matter of seeing if you can match up the correct sides. What I'm going to have you do when we actually solve these out.
What does the R stand for?
Angular.
What?
The angle.
How does it relate?
I'm getting there.
Okay.
So when you guys actually are solving these out, like the first thing I'll ask you to do is kind of focus on the angle that is either given to you numerically, or like in a problem like this, they actually say, like sine of r is telling you to look at angle r. Okay? So I would go, here's my angle r. And then since sine, cosine, and tangent are made up of opposites, hypotenuse, and adjacent, I'm going to label the sides opposite, adjacent, hypotenuse. Those words are always related to where this angle is. This side right here is the longest, so I know that's my hypotenuse. This side right here is the one that's actually touching this angle. So that's the adjacent one. Adjacent means it's touching it. And that just means that this is the only one left, which is opposite. Usually these are the two. All right, so here, a problem like this, once you get this labeled, once you say, okay, they're telling me to look at R, and you focus on R and you label the sides as opposite, adjacent, hypotenuse. The question is simply saying, put the numbers in to each of these fractions. Don't do anything else with it. It's just a matter of seeing if you can match them up correctly. So it's a matter of identifying opposite, adjacent, hypotenuse. So you would have to remember what the definition for each one is. Like sine is defined as opposite over hypotenuse. Cosine is defined as adjacent over hypotenuse, and this is opposite over adjacent. So if you can remember the definitions, and if you can label the triangle correctly, now it's just a matter of taking in the numbers that you've labeled as either opposite, adjacent, whatever, and filling them into the fractions. So just like for the top one, what number do I have for opposite?
45 over 53.
There you go. Adjacent was the...
28 over 53.
Okay.
45 over 28.
That's it. Like they'll give you a triangle, like a right triangle, they'll give you one of the angle measures. Since triangles add up to 180, you can find the other one, so it doesn't really matter which one you pick. But what you should do is kind of like circle it on the picture, and then once you circle it, label the sides opposite, adjacent, hypotenuse, and don't change it. Like stay consistent with that angle until you get like good with this stuff, and then you can maneuver however the heck you want. Because however you do these first two steps is going to lead you to being able to pick, do I use sine here? Do I use cosine? Do I use tangent? Because depending on how you label these is going to be how you pick the correct trig ratio. So if you label the triangle and you have the hypotenuse given to you and you're trying to find the opposite, you would use sine because it involves opposite and hypotenuse. So it's, and then once you pick the trig ratio, you set the proportion up and you just essentially cross multiply. Okay? And it's going to be pretty beneficial for you if you actually do the act of cross multiplying. I'll show you what I mean in a second. Give me an angle measure.
57.
57 is the first problem.
8.94. Mr. Collector, you play favorites?
62.
No, give me a number.
67. 0. 67.
Actually, put 7 out there.
12. 7.
Okay, so here's the thing. All right. This would be an example of what would be a very basic problem in terms of finding a side length with trig. Because it's only asking to find one side. They give you an angle, they give you a side length, you're good to go. So this would be just a problem saying something like, find the value of x. Okay? So here's the thing, it's a right triangle. So like in your head, when it comes time for any of the tests, your head needs to go, it's a right triangle, meaning I'm either doing a Pythagorean theorem here, or I'm doing a trig ratio. For Pythagorean theorem, I have to have 2 side lengths. I only have 1 side length given to me, so that's gone. For me to use my trig ratios, which again are just your sine, cosine, and tangent, I'll go through the steps that I would have just had up there, meaning I look at the angle they give me, which is right here. If you don't want to use this angle, if you want to use the one up there, that's fine. You can find it. It just takes you that extra step to get this number before, you don't want to waste time too much. So here's my angle. So I said, look, once you know which angle it is, label the sides. Like this is the longest side, so that's my hypotenuse. This is the side that's actually coming in contact with that angle, so it's the adjacent one. It's opposite. So now I can throw out the adjacent side because there's nothing labeled on it variable-wise or number-wise, so I don't even care about that. Meaning the way I select which one I'm using, I have to pick the one trig ratio that uses both opposite and hypotenuse. And that would be this one. Okay? Because so sine is opposite over hypotenuse, so those are gone. So basically, so now I know how I need to set my problem up. The way you write your equation out, when it says when that last step said set the proportion up and solve it. The way these get written is you do sine, and then to make this a numerical value, you have to put the actual angle measure there. This is the value you either get from your calculator, from the sheet I just gave you. So on like the left-hand side, normally you'll write this. On the other side, you're going to write what the actual ratio is. So since sine was opposite over hypotenuse, since I need this to be a proportion, I want these to actually have numbers and variables and stuff in it. So the side I labeled as opposite is x, and the hypotenuse is 7. So that's the setup. So again, this value right here you get from your calculator or from that sheet. This is set up based on what you labeled on the triangle. Okay, so I need someone to tell me what's sine of 57.
0.83672568.
83 what?
8.84.
67.
83867.
87.
Favorites today?
No, 867. Yeah, that'd be
Yeah, but around.
0568.
All right, so here's what I said also is keep this in mind is try and do this as cross multiplying. Meaning, if you have like a decimal or something sitting there, put it over 1 just to kind of in your head remind yourself that you are actually cross multiplying. For a problem like this, it isn't that big a deal, but the next one I do, it will be. So in terms of me cross multiplying, this would be like 1 times x. 1 times x is just x, correct?
Yeah.
And then 7 times 0.8387 would give me the other value, which normally when you get here, I would say round to the nearest 10.
5.8 or 9.
Is it 8 or 9?
It'd be 5.9.
5.9. And that, same type of problem. There's a right triangle. I'm saying find the side length. I do not have two side lengths, so I can't do Pythagorean theorem. Meaning you gotta do sine, cosine, tangent.
Couldn't you just find out?
So, in order for me to do this, this is the angle they give me. Okay? Once you focus on the angle, label the sides. This is the hypotenuse, correct?
Yeah. The adjacent's the one with the line.
That's adjacent.
Opposite.
That's opposite. There's nothing on the opposite side, so again, I don't care about that. Cosine. And when you set it up, again, it's always cosine or whatever your ratio that you're dealing with is. And then you put the angle after it, and then you actually write out the ratio. So it's cosine is adjacent over hypotenuse.
It'd be 0.4694.
0.4694.
Yeah.
Okay, so in this case here, this is where making sure you set it up as a proportion matters, because there's going to be people that do like 5 times that number, and that's not right. Okay, in terms of you cross multiplying here, this 1 is multiplied by the 5, so 1 times 5 is 5, and then the x is multiplied by whatever the heck that is, 0.4694. Okay, now again, I'm saying do that step just so, alright, do that step just so you'll remember now you've got x times a number. So if you've got x times something, to move it to the other side, you gotta divide. So this would become x equals 5 divided by 0.4694.
10.65.
10 point,
Wait.
yeah?